Trig Identities, Day 6. So today let's do another example with trig identities. We're still going to use the same rules that we have, but let's do some secant tangent. So we have, let's say we have a secant of x minus a tangent of x and a sine of x, and we want to prove that it equals 1 over secant of x. I always find that it's easier to go smaller than smaller to go bigger. So let's do the left side and make it equal the right side. So we want everything in form of secant of x, okay? And if we think about it, secant of x is our inverse to our cosine of x. So if I'm gonna keep this the same, the first part, but then the second part, I'm gonna change my tangent of x to sine of x over cosine of x, and we'll see where we go from here. And then times over the sine of x should be, and we don't need that equal sign right now. Okay. Keep going down, secant of x minus sine squared of x over cosine of x. Okay, I know sine squared of x is equal to, I can make both of those sine of x. I could also change the first one. Since I want all the functions to be the same, secant of x is the inverse. So here, this is secant of x is also 1 over cosine of x, right? And this is minus sine squared of x over cosine of x. I can then merge those two functions together. So this is 1 minus sine squared of x all over cosine of x. And 1 minus sine squared of x, remember our Pythagorean identities, that is the same thing as saying cosine squared of x. And cosine squared of x over cosine of x, we can reduce that to just being plain old cosine of x. And cosine of x, as we know, is the same as 1 is the inverse of 1 over inverse of secant of x. So here we have it, proving that that function, it takes a few steps, secant of x minus tangent x sine of x is the same thing as the inverse of 1 over secant of x. Or we could have just said cosine of x. Let's do another one. So let's say we have secant of theta, and we have sine of theta over x and theta are interchangeable here because they are the same thing, plus the cotangent of theta, and we want to prove that is the same thing as sine squared of theta. Okay, so let's think about this logically, right? Sine squared of theta is the same thing as saying 1 minus cosine squared of theta. So I'm going to keep that in mind as I work through this. I'm going to manipulate the left side, I'm picking the left side to do because it's easier to go small. So let's see here. I want everything in terms of sine and cosine. So I'm going to go through and I'm going to change everything in terms to sine of cosine. Secant is the same thing as 1 over cosine. So this is 1 over cosine of theta times sine of theta all over tangent of theta is sine of theta all over cosine of theta, plus cotangent of theta is cosine of theta all over sine of theta. Let's simplify this a little bit more. So here, the top, the numerator, I'll say this is sine of theta over cosine of theta. And my denominator here, and then my denominator is still sine of theta over cosine of theta plus cosine of theta over sine of theta. Now let's see here. If I multiply everything, the numerator and the denominator, if I multiply the numerator and the denominator by cosine of sine of theta times cosine of theta, I can get rid of all the messy denominators. I can do that here. So let's do that. If I multiply everything by, so that the numerator becomes cosines cancel each other out. So then this is just sine squared of theta in my numerator. In my denominator, my first term, the cosines cancel out, so I have sine squared of theta. In my second term, my sine of theta cancel out, so I have cosine squared of theta. Oh, and look at here. Sine squared of theta plus cosine squared of theta is equal to 1. So this is equal to just sine squared of theta. And that is what we are supposed to find. And we're done.